Hi, my lovelies. So here we are in another episode of Heads Empty Just Digicom 2022. So, as you can see, the theme of these episodes are just ways to do this and not actual understanding. Therefore, if you have more time, I mean, we don't have more time, I guess. Just go learn things. Anyways, so adaptive Huffman is actually adaptive of Huffman code, which is, I guess, a little bit harder version of the Huffman code. And we are basically building a tree. So if you have been in data structure class before, then this would seems pretty familiar to you, I guess. And since Ajahn told us specifically in 2022 finals exam that it's not gonna um tell us to decode stuff, it's just gonna tell us to encode stuff, which means we're gonna get a message like this, and we need to turn it into zero and ones. So we'll encrypt it character by character. So I will just tell you the part where we encode stuff and not the decoding one, because why, right? It's like 1 a.m. in the middle of the night before exam. Therefore, yes. Anyways, so some basic rules. So actually, this is the procedures of how to update the tree or how to encode the adaptive Huffman. If you can remember this, then that's fine. If you don't, then that's fine also. You will remember it by doing it. So if you can want to read, you'll see that there's two main factors. Firstly, it's that if you see any character for the very first time, then you will be declaring an NYT, which honestly I don't know what it stands for, but I'm guessing it stands for not yet there. Lol. Anyways, plus a fixed code. Fixed codes is what they have given you, or like the initial codes. But if you have already seen the character, for example, this A, there will already be an A in the tree, and therefore you can reference the code from the tree itself, right? So let's see how this works, right? Okay, let's try. I will put it side by side, therefore you can reference to where the slides are. Okay, like this. So the message that we are gonna encode is A A B C D D, right? Like this one, right? This is quite a simple one. But all logics are the same, and if you want more info or more examples, just ask me later, which means like tomorrow. Anyways, let's start. So we always start with a zero, right? A tree, a simple set tree called zero. And we have an index, and it's a not yet there right here. Therefore, this not yet there in the first part, in the first character, we can actually omit it, right? So when we want to put in any characters, we just basically do this. We just do this, right? And this. This is like the basics. So let's see. Let's add our first character. Do this, right? A. Yeah. And this. And then the not yet there will be here right now, right? And we can actually have it, reference 17, 16, like this. And another thing is that whenever you update the children node, you need to update the parent node as well. And you need to update the parent node until it reaches the root. So, like for example, the parent node will need to be A1. So it's an A, and we can actually omit the not yet there. Therefore, we just base it on the fixed code, which is 0, 0, 0. Done. This one. See, we just add the new symbol there. Now, let's move on to the second A. When we see the second A right here, right, this goes to the procedure of already being in the tree. Therefore, we just do A, and then we have like the 0, 0 from before, right? And we can label left as 0, right as 1. So this A code will just be 1. and then we can update the tree. Like this. Simple, right? See? Update. Now, moving on to our B. Since our B was the first time that we have seen this in the tree, therefore we need to declare a not yet there, right? So in declaring a not yet there, let's see, the not yet there is right here, right? So like if you want to add new nodes, it would come here, right? So with our former code, the not yet there will be a 0 because of this. And the fixed code for B is actually 0, 0, 1. So we add 0, 0, 0, 1. And then we draw the tree. It is recommended not to draw like the parents or the root nodes, or else you're gonna need to fix your tree. Now we have A, B. This is a B, this is a 1, and this is a 3. So you can do this 0, 1, 0, 1. Okay? Next, we have A, B, and then we have C. So C is also a newcomer. Therefore, we need to declare a not yet there also. Let me move this to here so it can be easier. A newcomer, right? So a newcomer, we will need to add a not. It would be right here, right? So the not yet there would be a 0, 0. So A, B, C. 0, 0, 1. A not yet there would be a 0, 0, and the fixed code for C is 0, 1, 0. Now let's do this. And it's gonna be a 3. Sorry, it's gonna be a 2A. It's late. I'm sleepy. It's gonna be a B. It's gonna be a C. This is 1. This is 2, and this is 4. Now we are happy. Next, let's move on. So, as you can see, here, I forgot to, here is the tree, right, at C. Now, we are moving on to the next one. We have encoded A, B, C, right? Now we're facing D for the first time, therefore, we need to actually declare a not yet there. So so this not yet there, right? It's like right now, if you put all the left for 0 and all the right as 1, the not yet there for D, this is, A, B, C, D. And let me copy this here because I'm too lazy to actually write it again. Honestly, I don't know why I'm actually explaining this in English, but I hope you understand. Lol. Anyways, so D, the not yet there part will be here because we're adding it hopefully to here. So it's a 0, 0, 0, right? 0, 0, 0. And then the D fixed is a 0, 0, 1, 1. Now, the problem does come because if you see it clearly, this, if you add, right, you add a 0 and you add a 1 as a D, then this will be a 1, this will be a 2, this will be a 3. And this comes a problem because 2 is actually lower than 3. Therefore, we need to switch these branches. And therefore, we're going to do the switch. I mean, different people have different ways on how to do this, but I just prefer to do it this way. Like, I see it, and then it's going to be a 5, right now. And then the left part would be a, like this one, right? And then we would have a 3 here. And then since the 3 here is actually this one, right? So this is gonna be, if you add this is gonna be a 1 and a 2 and a 3 and a 5, and 2 exceeds 1, so you need to switch these also. So it would be a 2 right here. This would be a 1b. A 2 right here with 1, C, 0, 0, 1. D. As you can see, there's 2 switches. So we actually switch the big branch here, and we actually switch the B right here to be on the left branch because it's lower. Now, let's see. See, this is the result. You can actually label it, right? Every left is a 0 and every right is a 1. Now, to our final D, we already have a D in here. So it's very easy, right? You just do, how to find D, it's 1, 1, 0, 1. So our final would be A, B, C, D, D. And it would be all this. Let me copy this again. With a 1, 1, 0, 1. 1, 1, 0, 1. And that's a D. So you can actually update the stuff, right? So because like if you update this will, honestly I did this wrong. This was supposed to be a 1 here. But yeah, if you update this to 2, right? This will be 2. And with this being 2, this will be 3. So you actually to switch this one with this one as it exceeds each other. But anyways, that's the gist of it on how you encode this, right? So it's a 1101. You can see right here and right here. And that's all. So hope you have fun with adaptive huffman. Yay!